Welcome to Science on the Board. Let's explore amazing science ideas together, one lesson at a time. Imagine this: a kid playing Lego in his toy car at the beach when some of his Lego pieces get mixed with sand water. If you're asked to help, how would you separate these materials? Let's find out what you can do in this situation as we explore the different techniques used to separate mixtures. Today, we're going to discover 8 simple techniques for separating mixtures that you can see in everyday life. Remember that a mixture is made when 2 or more substances are combined without changing into a new substance. Since the substances keep their own properties, they can be separated again. For example, sand stays solid while water stays liquid, making them easy to separate using the right method. But, how do we know which method to use? It depends on the size, weight, shape, and other properties of the materials. Grandma is preparing rice for dinner. Then, you notice tiny stones mixed with the rice. What can be done? Pour water on it? Use magnet? Yes. Simply remove the stones by hand. When materials are large enough to be seen, we can remove them by hand. This method is called picking. It is used to separate components based on visible differences like color, type, size, shape. Other examples are separating specific items from a snack mix and removing bottle from trash. Let's look at the next example. Ice cubes in a glass of water. What if you want to remove some of the ice cubes, so it won't be that cold to drink? What can you do? Would filtering be the easiest way? Not really. Since the ice cubes are already floating, we can simply scoop them out. Scooping is a method of separating a mixture by using a spoon, ladle, or net to remove materials that are floating on the surface. It is commonly used when one component is lighter than the other and can be easily scooped out without removing much of the liquid. Examples are scooping cooked beans or removing floating leaves in water. Here's another challenge. We have flour mixed with tiny iron filings. At first glance, it looks difficult to separate them because the iron filings are so small and mixed all throughout the flour. Would you separate each tiny iron filing one by one? That would take a very long time and be very tiring. Can you think of a faster and easier way? Also called magnetic separation, it is separating a mixture using a magnet. It is used when one material is magnetic and can be easily attracted by a magnet, while the other material is non-magnetic and remains behind. Examples include magnets used in scrapyards and mining. A man is collecting sand for a construction work. As he checks the sand, he notices that it is mixed with gravel. Since the sand and gravel are mixed together, separating them might seem tricky. What can he do? Can he try removing the gravel with his hands? Now, think of a quicker and easier method. That's right, a sieve. A sieve has tiny holes that allow the fine sand to pass through while the larger pieces of gravel stay on top. Used when the materials have different particle sizes, allowing the smaller particles to pass through while the larger particles remain behind. Examples are flour being sifted to make it finer and remove lumps and straining cooked pasta from water. Look at these 2 glasses. One is filled with muddy water, while the other is clear. Can we make the muddy water clear again? Is it possible to use a strainer? Yes, you can use a filter. A filter, such as filter paper or a clean cloth, has tiny holes that allow water to pass through while trapping the mud or soil. It is used when the liquid passes through the filter, while the solid is left behind. Examples are brewing coffee and DIY water filtration using cloth and layers of pebbles and sand. When we prepare rice for cooking, we first wash it. But, how will you remove the water without pouring the rice out? Right, let the rice settle in the container before carefully pouring out the water. This method is called decantation. It works when a solid settles at the bottom, allowing the liquid on top to be poured away. Examples: In solid-liquid mixtures, the liquid is poured off while the solid stays at the bottom, such as sand and water. In liquid-liquid mixtures, the lighter liquid is poured off while the denser liquid remains below, such as oil and water. Here's another challenge. Salt is dissolved in water. Can you still see the salt? No, it has completely dissolved. So, how can we get the salt back? Can we use a sieve or a filter? How do we separate them? You got it, evaporation. When we heat the salt water, the water evaporates into the air, leaving the salt behind. Examples are separating salt from seawater and drying wet clothes in the sun. Let's look at our last sample mixture. We have here a lot of husks and some rice. Can you separate them by picking them one by one? Think about this. The husks are much lighter than the rice grains. What can help carry away the lighter husks while leaving the heavier rice behind? That's right, winnowing. In winnowing, we gently pour the mixture from one container to another while the wind blows. The lighter husks are carried away by the wind, while the heavier rice grains fall straight down into the container. This is show farmers separate wheat from chaffs or husks from grains. For our quick challenge, which method will you use to separate the components of these mixtures? Good job! Today, we learned that there is a right technique to safely and efficiently separate the components of a mixture. Remember this bucket from the beginning of the video? Can you figure out how to separate each material? Comment the steps in order. Great work today. See you in the next lesson. This is Science on the Board. Keep exploring. Keep learning. If you enjoyed this lesson, don't forget to like, share, and subscribe for more simple science lessons.